The International Energy Agency estimates that by 2050, the demand for air conditioning will increase by 350% when compared to current levels. To mitigate and manage those climate change impacts caused by the operation of air conditioning systems, it is essential to promote energy efficiency solutions in existing and future buildings. Energy districts are an alternative. What characteristics must an existing building have in order to connect to a cooling district? What are the necessary retrofits? The most common case of buildings ready to connect to a cooling district refers to those buildings already equipped with a centralized chilled water production plant and distribution systems. Such buildings operate their own centralized water chillers and convey the chilled water from the chillers to the air handling units, AHU, on each floor by using internal chilled water distribution networks. In these cases, the connection to an outside district cooling service is simply achieved by removing the chillers, replacing them with a heat exchanger that will transfer the cooling energy from the district chilled water side to the existing internal distribution network of the customer building. Modifications to the existing internal building energy systems are not necessary. However, it is quite common that, during the district connection preparation phase, energy efficiency and system optimization opportunities are identified, mostly in the internal pumping, heat transfer, and ventilation systems. Nonetheless, it is strongly recommended that the identification and implementation of these energy efficiency measures be carried out regardless of whether the cooling is produced locally or is contracted as an outsourced service from a cooling district. Another type of existing buildings potentially connecting to an external district cooling service is the case of those that supply their air conditioning needs with the centralized or direct expansion systems, where each space or room has an individual air conditioning system, such as split or mini-split units. In these cases, the connection to an energy district is technically possible, but it requires repurposing previously occupied spaces and breaking through walls and ceilings to accommodate the heat transfer station, the connection point to the external district cooling supply, and the construction of the building new cooling water piping network, including the new air handling units. When the existing internal units are of mini-split type, the spaces previously occupied by the condensing units and the refrigerant piping routes can be partially used to give way to the new internal chilled water pipe system. Finally, for much older buildings, or those with no or very basic cooling systems, like window AC units, the connection to a cooling district would require a very costly and unprofitable level of intervention. In all cases, depending on the type, age, and deterioration state of the equipment to be replaced, there are different options for reusing or recycling their components. Keep in mind that any use or destination must comply with current regulations on waste disposal from cooling and refrigeration equipment. Be advised that by regularly auditing and analyzing the operating conditions of your building's cooling and energy systems, valuable information will be produced to subsequently justify the eventual connection to the nearest energy district, to update your air conditioning systems, or to implement any other energy efficiency measure eligible for tax incentives, as offered by many national governments. If your building meets any of the aforementioned characteristics and you wish to connect or get information about energy districts, please visit www.distritoenergetico.com.